This is the pre-lab video for the multi-step reaction sequence that we've been doing. And 2 weeks ago, you guys all made this ketone. You have different ketones depending on what your R group is. And this week what we're going to be doing is we're going to be doing the second half of this reaction, which is a Grignard reaction. So to do this reaction, the first thing that you're going to have to do is you're going to have to prepare a Grignard reagent. And then you're going to take this Grignard reagent and you're going to react it with your ketone to give you this alcohol, and you have made right here is your new carbon-carbon bond. Now, all of these reactions occur in a 1-to-1 molar ratio. For example, for every 1 mole of bromobenzene, we're going to need 1 mole of magnesium, and that's going to give us a 1 mole of the Grignard reagent, and then that 1 mole of Grignard reagent is going to react with 1 mole of your ketone to give you 1 mole of your product. Now that's how the reaction occurs in a perfect world, but our world is not perfect. And because of that, we're going to make an excess of the Grignard reagent. And in order to do that, for every 1 mole of ketone that we have, we're going to use 1.5 moles of the bromobenzene and 1.65 moles of the magnesium. And the reason for that is the phenylmagnesium bromide, or the Grignard reagent, can react with water to give us benzene, which is one of the side products in this reaction. And while we are going to make every effort possible to minimize the amount of water that is present, there is going to be some around, so that's why we make an excess of Grignard reagent in order to react with it, and then we should have enough left over to react with our ketone. Alright, so let's do some soluble calculations, assuming that last week you had started with ethylbenzene, and so you ended up with this ketone, and this ketone would have a mass of 148.2 grams per mole. The other masses that we're going to need to do the calculations are 157.01 grams per mole for bromobenzene, and finally 24.31 grams per mole for magnesium. Now to start, the first thing we have to do is figure out how many moles of our starting material we have. And let's assume that last week you found you made 4 grams of your ketone. So using the molecular weight, we determined that we must have 0.0270 moles of our ketone. Now we need to figure out how many moles and then how many grams of bromobenzene that we need. So we use the stoichiometry of the reaction here, and we know that for however many moles of ketone we have, for every 1 mole of ketone, we need to use 1.5 moles of bromobenzene. Now this is, as I said, this is just a 1-to-1 reaction, but we're using an excess of bromobenzene, so we get an excess of Grignard reagents in case of side reactions. And that would give us then 6.359 grams of bromobenzene. Now we need to calculate the amount of magnesium we're going to use. We start off with the same amount of the ketone. Now we're using even more magnesium than we did of the bromobenzene. Part of that is because magnesium is a solid, and it's very difficult to get all of that solid to react. And we have this many moles of magnesium, and we can now convert that to grams of magnesium, so that means that we have, we'll use 1.08 grams of magnesium. So the setup for the reaction this week is exactly the same as last week. And once again, it's very, very important to keep everything dry, and that's because, as I mentioned when we were talking about the calculations, when you mix together phenylmagnesium bromide and water, you get benzene. Benzene is not a good nucleophile. It's not going to do anything in the reaction. So when we're making the phenylmagnesium bromide, the first thing we're going to do is we're going to dry this entire apparatus with something called a heat gun. You can also do this with a Bunsen burner flame. We use a heat gun. The heat gun looks like a big blow dryer, except for if you just tried to use it to dry your hair, it would set your hair on fire. So please do not do that. Once your apparatus is dried and cooled, then what you're going to do is, to the reaction flask, you are going to add the magnesium, you're going to add 5 mils of your ether, and you're going to add about 1/3 of your bromobenzene. Then you're going to stir all that, and you may add a crystal of solid iodine, which can help initiate the reaction. As you're stirring it, you should stop periodically. You'll warm the flask with your hands, and you should stop the stirring periodically to see if you see any bubbles around the magnesium. And when you see that, and also the iodine is brown and it'll go clear when the reaction is initiated, in addition to seeing the bubbles. So once the reaction starts, it generates enough heat that it refluxes and keeps on going, as long as you still have bromobenzene in the reaction mixture. So then to the addition funnel, you're going to add a solution of the other 2/3 approximately of your bromobenzene and the rest of your ether. And then what you'll do is, so there's that solution. So then what you want to do is add it dropwise to this solution, so that it will keep you don't want it to add it all at once because it'll just all boil out. But if you add it dropwise, that's enough to keep the reaction going. And then once you've added all of this solution, then we'll reflux the reaction mixture on a hot water bath for 15 minutes. So now hopefully you'll have a nice solution of phenylmagnesium bromide and ether. You may still have a few chunks of magnesium floating around. Remember, we added up an excess of it, so it's not all going to react, and that's perfectly okay. So now that we have that, what we're going to do is we're going to have your ketone and your ether, and we're going to add that solution dropwise to the phenylmagnesium bromide. And recall that a Grignard reagent reacts like it is an anion, which is a good nucleophile. So that's going to react with your ketone by nucleophilic addition to the carbonyl, giving you this alkoxide, and there is your new carbon-carbon bond. Okay, so now you've got, as I said, your alkoxide, and so now what we're going to do is we're going to add ammonium chloride. There's our ammonium chloride solution, and we're going to add that dropwise, and what that is going to do is it's going to react with the alkoxide, where R is all those aromatic rings and stuff, and give us the alcohol plus ammonia. And the drying tubes that were up here, since we're adding a aqueous solution of ammonium chloride to the reaction mixture, we're quenching it where we don't need to worry about keeping it dry anymore. Now in our reaction, we have a mixture of an aqueous solution and an organic solvent, ether, and we'll use, just like we did last week, we'll use a separatory funnel and an extraction process to isolate our product. As I said, it's a very similar process to last week. One of the key differences, though, is now we're using ether as our organic layer. And since ether is our organic solvent, it is less dense than water, so that means this time our organic layer is going to be on top. Okay, so now I'm ready to do my extraction. Notice in my separatory funnel I've got my organic, which is my red layer here, and I've got my aqueous layer, which is the lower blue layer. So, and I've got my 2 Erlenmeyer flasks that are labeled so I know what is what. And the first thing I'm going to do is I'm going to drain the lower blue layer, into, or the aqueous layer. I wish it was going to be blue. That would be a lot prettier, but it's not. So drain it into the flask. Okay, so now what I'm going to do is I'm going to add 15 more mils of a saturated ammonium chloride to the separatory funnel. Alright, so there's my additional, I think it's 15 mils of ammonium chloride that I've added. So now I'm going to shake that up, and then what I'm going to do is I'm going to take my flask that has the ammonium chloride in it, and I'm going to drain, after I've shaken it up, drain this in to there. Okay, now that I've done that, I can set this to the side, and then I'm going to take my flask for my ether layer, and I'm going to drain this into that flask. And now that I've got the ether layers, I'm going to put those to the side. I'm not going to throw those away. And now I'm going to take my combined aqueous layers, and I am going to pour them, well, I need to put this up a little higher, right? Okay, so I'm going to, I can't quite do it, pour them into the sep funnel. Well, look at that, I miraculously didn't spill any. Okay, so now that I have my combined aqueous layers in there, what I'm going to do is do something called a back extraction, and so I'm going to add 10 more milliliters of ether to the separatory funnel, and I'm going to shake it up, and the idea is to pull any organics that might be hiding in the aqueous layer into the ether layer, so I get a maximum yield. And now I'm going to, once I've shaken it up, I'm going to drain my aqueous layers into this flask. So now I have aqueous layers, and I can set them to the side. And then I take my previous ether layers, and I'm going to take this 10 mils, and I'm going to drain it into here. Alright, so now I have what is hopefully my ether layers containing my organic products. So the next thing I'm going to do is, that's where I hope my product is, the next thing I'm going to do is I am going to dry. So now I'm going to take my ether, and I'm going to pour it back into my sep funnel. And now I'm going to wash the ether layers by adding some saturated sodium chloride solution. And that's an aqueous solution, and because it has so much salt in it, it helps pull any water that might be in the ether layer, pull it out of the ether layer. So once I've shaken that up, then I can take my flask that contained my ether layer, and I can drain my ether layer into it for the last time. Alright, so I can take that ether and put it to the side, and if I wanted to be super complete about it, I'd go ahead and drain my aqueous layer and keep all those. But now, hopefully, the star of the show is this guy right here, and so what I'm going to do is I'm going to add magnesium sulfate to the ether layer, and remember, you're going to swirl it, and you're looking for, don't be shy, cover the bottom. As long as you don't add more magnesium sulfate than you have solution, you're going to be okay. But remember, we're going to look for the solution to get clear, and you're looking for the magnesium sulfate to be flowing and free, like the analogy I use is a snow globe. I don't know if that's perfect, but that's what I've got. If you've got a better one, let me know. So once you've got your solution, you want to gravity filter using fluted filter paper into a tared, meaning pre-weighed, round bottom flask. Then we're going to rotovap it. And normally what we would do is we would do a purification step with this, where we would do something called column chromatography, which is basically a preparative type of thin layer chromatography, but we are not going to do that last part of the reaction, so we'll just, this is the point at which we'll stop and analyze our product. Now, as I mentioned, we're not going to do the purification step where we do chromatography of this, column chromatography, but we will do thin layer chromatography. And at this point, you're going to have a mixture of your products. You're going to have your alcohol. Hopefully that is what most of what you have is the alcohol that's your desired product. You may have a little bit of starting material left over. And it's also highly likely that you're going to have a compound called biphenyl. And biphenyl comes about because one of the side reactions that we have not mentioned is a Grignard reagent can react with an alkyl, in this case an aryl halide. And it's not a very good reaction. That's why we use lithium dialkyl cuprates instead. But it can happen, especially if you have a lot of bromobenzene around and some of the Grignard reagents. So it can react to give you biphenyl. And what we're going to do is we are going to take these products because they differ greatly in polarity, and we will take a drop, dissolve it in some of your product, dissolve it in some dichloromethane, and then you should save a little bit of your ketone so that you can spot it against the product, and also I will give you some biphenyl that you can spot on the TLC plate. And then what you can do is you can compare that to your product mixture to see if any of the ketone is still present and if you made any of the biphenyl. So that's about it. I will say that Rudy and Dudley are very interested in seeing what your results are this week.